My name is Dorota. I'm leading Fusion Operate team in Finastra. I will tell you a little bit more about the team later. Today we are here to tell you a little bit about our journey of adopting NoOps model in Finastra in our project, which is FFDC. This is Finastra's platform project, and I will pass to Łukasz to tell a little bit more about it, give you the context.
Okay, hello everybody. My name is Łukasz. In Finastra, I manage a few teams involved in development of our platform, so the Fusion Fabric.cloud, mentioned by Dorota. To put you in the context, on the first slide, I will just explain what FFDC is and why we made it. So our customers are banks and financial institutions, and banks used to be a bit behind in adopting new technologies, but it is changing during last years. They want to benefit from new technologies like the ones mentioned on this slide, but they have problem to catch up. So more and more they want to cooperate with fintechs, which use these technologies. We want to help them to achieve it, because these technologies are used in many sectors, and for sure they will be used in finance as well. So, especially for API economy, you will see on the next slide that this is something which our platform helped them to achieve. So. Two actors which I will mention here. So fintechs want to collaborate with banks. They need to have access to banks' data, to banks' clients, and they want to work with them, but they have problems that usually it is difficult to get to the bank, and even if they get there, it is very slow to deliver something to production or to deliver new functionalities. Banks. They are slow because they have many restrictions, like some regulations and stuff like this, and they are focused on their core activity, which is banking. Smaller banks does not have big R&D teams, but they want to cooperate with fintechs. Usually they can choose only few and work with them, but they would like to have a broader ability to work with many fintechs. So as you can see, there are problems to connect these two actors, and even if they are connected, it is slow for them, the cooperation. So we believe that collaboration is a very important aspect, and this is where platform comes to help with this. So platform Fusion Fabric.cloud supposed to connect creators of applications and solutions. So it can be fintech bank, it can be software vendor, it can be even students from universities with consumers, so financial institutions. The idea is that all banks they have already core systems. They have usually many core systems for different type of banking. You can see them at the bottom. It can be core systems from Finastra, but it can be core system from whatever other vendor. And the main idea is that these core systems should expose REST APIs, which might be then consumed by newly created applications. And then platform consists of three parts. Fusion Creator is the first one. So this is kind of developer portal where developers create their application. They decide which APIs they want to consume, and then they request from banks to give access to data of a bank or concrete tenant in a bank. Second part is Fusion Operate. So this is a runtime in Microsoft Azure. It consists of many pieces. One of them, important one, is the microservices, which are running in Docker containers managed by Kubernetes. But there is much more here. And the last part is Fusion Store, so the place when creators of applications, they promote their app, they want to sell them, and consumers can see, view, validate, and buy them. So now quickly about challenges. During the development and now during support, we face many challenges. Of course, we face, let's say, standard ones which apply to every solution development, like time to market, total cost of ownership, but we also had specific challenges which came because we brought together these two different actors. So fintechs that have different needs. They want to monetize on their apps. They want to increase their revenue thanks to this, and again invest it in innovation and in their growth. While financial institutions, they want to increase their competitiveness, so they want to bring new functionalities easily and quickly, but they also want to be able to foresee what's the cost of adding these new functionalities. And for them, it's important to secure their market shares. Ideally increase it, but for sure not to lose it for other growing fintechs or banks. So we have many expectations for high availability, no downtime, and in the same time we should be able to deliver continuously new features. So as you can see, we have many challenges. They are really difficult, and we want to show you how we approach to still provide reliable solution. Knowing that usually even if you try to avoid problems, so you try to avoid your destiny, in the end you will meet it anyway. And by solving one problem, so introducing some changes, you can introduce other problems. So we assume that you cannot escape from incidents. They will always happen. You just need to prepare for them. So you have to have proper solutions, proper tools and processes to solve them when they will come. Yeah. So we will not show you how to avoid problems. We will rather concentrate what to do to be ready, to be able to deliver a fix quickly, to react and deploy something to production in a short time.
So according to cloud architect at Netflix, Adrian Cockcroft, it's a quote that NoOps means automation of deployment, monitoring and management of applications. And actually this does not mean that you can totally abandon operations, but you need to think about having built tooling to remove this burden of operations from a developer, and if there are any left, you need to think about how they can be resolved in a fast manner, and most of all, there should be self-service. So I will tell you a short story of a developer. So developer is someone who wants to focus mainly on their core activity, and this core activity is obviously coding. They don't want to pay so much care about infrastructure and about operations. They just want to focus on delivering new feature. And obviously for delivering new feature, the code is not enough. They need to run it somewhere. They need to deploy it somewhere to test it, and after that they need to deploy it to make it a service for end user. So it seems easy that you just, in the days of containerization, you just need to run your Docker container somewhere and that's it. But that's not all, that's not enough. You need to think about where to put your Docker image, if the way of storing it is secure enough, etc., etc. So there is a third factor in the picture. So these are corporate duties. This covers all the processes about software delivery process. This needs to provide you a way to make sure that the way you deliver your software is secure, and then that your software, that your services are running in a secure way, that they are not vulnerable, that you enforce quality gates, so that the functionality you deliver actually passes the quality gates, that it passes the test, that the code coverage of your test is good enough and the functional tests are passed. And after that, when you do the deployment, you need to make sure that in the end, your feature is traceable and auditable. So you need to make sure that you know which version introduces your change. And if during this change introduction there were all the quality gates passed, And once you deploy, you need to make sure that your infrastructure and your software is monitored. So between those three factors, the developer and the infrastructure and all these processes and the governance, there is a missing factor. And we are trying to be this link as Fusion operate between those three factors. And we are trying to deliver processes that will allow it to all play happily together. And Fusion Operate is the team, but it's also a platform runtime, and our team is working on making it work. So in our mission statement is integrating, automating, and then supporting it. So there is one side of the story where there are a lot of pipelines. Here are the main areas that where the pipelines are defined. So first of all, we have infrastructure deployment pipeline. So it is making sure that your infrastructure is reliable and it is always delivered in the same way, and you have all the resources that you need for your pipeline, for your delivery pipeline, and for your tests, etc., available. So here we are covering AKS, which is Azure Kubernetes cluster, container registry, databases, key vaults for storing secrets, and all other cloud resources that need to be deployed to make the application run and integrate correctly. The second one is application build pipeline. It's for continuous integration. It's about producing an artifact, which in our case is a Docker image. And our build pipeline is prepared as code. And the third one, is application deployment. It's deploying to Azure Kubernetes, and it's called a release pipeline. We are using Azure DevOps project to define all our pipelines, and deploying is a release pipeline definition. So this is it on this side. But the other thing is processes governance. So we, on Fusion Operate side, we are making sure that the code review is in place. So we are enforcing policies, branch policies in Git repositories. So when a developer wants to create a repository, we are making sure that this repository has the branch policies enforced. There are quality gates enforcement, and this covers code quality checks, security scans, unit tests, integration tests, functional tests, end-to-end tests, and all those checks are integrated in our pipelines during different stages. And then there is a change and release management. So we are integrating with ServiceNow, and here we made it happen that finally, because of enforcing all the quality gates, we are able to have these changes that we want to deploy to production pre-approved in ServiceNow, so we don't need additional manual action and waiting for someone to approve manually, because the company is sure that having all those quality gates in place, we are delivering the reliable software to production. And then in the end, there is monitoring part that after you deploy, you have all your parts of the monitoring area configured already, because you have this all configured in your pipeline.
Okay, so now I will tell you a bit about how standard activities flow looks like for usual microservice, which is part of platform. You need to know that if you want to deploy something to production, especially in banking software, you have to comply with many regulations. It's not that easy. So Dorota already mentioned you have to allow full auditing, traceability of any change. So this is why we introduce such process to make it automatically, because normally such processes are not automatic. So I will very quickly just go through some steps which our development lifecycle look like. And on the left side, you can see several tools involved. So everything starts in Jira when product management is describing their needs. These are stories or bugs or whatever items you can have there. The tools and environments where development team is usually working is Azure DevOps. So we have Git repository there for the code, and CIA pipelines for all the tests which are running. When the feature is ready, it has to be validated, and again, it has to be somehow signed in Jira that it is traceable, that it was approved. And then when you are ready with your functionality and you have a concrete version of microservice which you want to deploy, you merge your pull request, and then there are plenty of scans which are happening to assure that the quality is good enough, security is good enough, and so on and so on. And only after that you have a build of your service, which is artifact, which later will be used to deploy your running service to different environments, and in the end, the production environment. The third tool which appeared there is ServiceNow, which Dorota mentioned a few seconds ago. And on the right side, you can see several items in these different systems which allow this traceability. So in Jira, you have IDs for each item, for versions, for stories, and so on. But also in Azure DevOps, you have commits, builds, releases, and the same for deployments in ServiceNow. So you can see some arrows there. It means that all of them are linked to each other. So it requires from us to make integration between these tools, which are on the left. But it was a must-be to allow this full traceability. So then we know that from the idea to the very end working software, what is the full track, and you can trace it and be able to make root cause analysis if you have some issue and you have to troubleshoot it or even reverse it. At the top of the slide, you can see several teams. I don't want to explain you all the details, but what I want to mention that normally in our company, all these teams have to give their approvals that we comply with company standards and that we comply with the demands from our customers. And only after that we can serve some software on production. And usually these processes are manual. And we have still in Finastra many products which have to apply to agree with these teams that they want to deliver something to production. And you can imagine that it takes days or weeks to get all these approvals before something is really deployed there. And what we did is we discussed with them what we have to do to make this process automatic. We got some agreements, and we made these steps to have this process fully automatic.
Okay, now I will tell you a little bit about our build pipeline. So it's a template as code, and it's stored in single repository. And as a developer, you want to build your application with a verified template so that you are compliant to all company processes, but also you want to make sure that this process is fast enough and does what you actually want. So on the side of the developer, there is a repository. I'm showing you a repository of our sample application, which is a template for practicing and experimenting with all this automation. And here you can see that it's enough to define a simple Azure pipeline YAML. So it's a manifest file, and just refer to the repository that you want to use, and define what kind of repository it is, what is the name, and even what the branch of this repository is. So having this little file and the reference template, you are able to just quickly use it and build according to what's defined in the template. So it might not be visible that much, but here there is a list of steps that are executed during it's a standardized way to execute every other build, every other service that wants to go finally to production needs to go through all these stages, the steps. So you have white source scan, you have sonar scan, there is also a checkmark step, and unit tests, and all of this needs to be passed. There are quality gates defined that there is no high and critical vulnerabilities possible, that you need to pass 100% of your tests, and otherwise you cannot go further. So here are just a little screenshots. There are the external tools that we are using for the scans are integrated with Azure DevOps, and you can just quickly see a final result of your scan that tells you that it actually passed and there is no issue to going further.
Yeah, maybe I will show you a real one, because so Dorota showed you a template, which then we consume as microservices when we are developing it. So, oops. So when a pull request is merged, then it is automatically generating a build. So the build is starting, and then we can see result of this build. This is an example of build which passed successfully. So this is exactly what you saw on the slide, but it is now for the real service, which is called app management in this case. And you have different groups of tasks which were done, and you can see the time it took, when it happened, and for each of them I can click and see the detailed results, what was there. And yeah, and here are the ones which were also on slides. So we have the aqua scan for container. It takes a bit of time, but yeah, I have a result that there was only a few medium and low issues. So it is approved. You have check marks. Yeah, like Dorota mentioned, it is integrated, so it has to take the data from other systems. So it takes a few seconds. No issues at all in check marks. In white source, no policy violation. So as well, everything was good. I can see code coverage, which also has quality gates. So we have 87% of code coverage, which is I'm happy about. So it is allowed to be deployed as well. And for tests, I have 100 parse tests. 400 of them are good. So they took 1 minute to run all of them. So we are happy, and such build can be deployed to different environments. And I can see that also that later this build was taken, consumed, and deployed on several environments from development up to the public phased one.
Okay, so on this slide you can see the actual release pipeline. So it's about deployment pipeline. We have a couple of stages. And what I would like to highlight here is that we are using Azure tools. So it's in Azure DevOps. You are able to define those stages separately, but inside you can define the task groups, that you can reuse throughout all of these stages. And then there are variables libraries that allow you to parameterize those task groups across the stages. And here is a small example where you can see the simple step within the task group. So it's a task group definition, and it's about deploying Helm chart. We are using Helm charts for Kubernetes deployments, and it just deploys Helm charts to the cluster. And it's a simple definition that you can define and then reuse across all other stages. And here you can see the set of variables used by all the release, and in this small unreadable, I think, letters, you can see that these are scopes. So actually these variables were used for this particular stage here, and you can track what happened where during the stage execution. Sorry.
So I will again just show a concrete example. So this is the deployment which happened on our publicly faced environment. You can see different steps again here. It looks similar, but there are completely different steps. They are happening after the deployment, not during the build process. You can see ServiceNow, which was mentioned on previous slides, that it's approved to be deployed on production. And again, you have different steps. I will not go through them, but you have test results as well here and so on. Again, for tests, everything is passed, but these are different type of tests, like I mentioned. You have some BARP, so active scan results. We need to wait a bit. It's always take this one, maybe later. And the variables and variable groups, which Dorota mentioned, are visible here, and the tasks as well. Yeah, so I can click it. I cannot change it because it's only Fusion Operating who is allowed, but I consume it as a microservice which is using the CI/CD pipelines. Here you have example of deployment which was not that successful. There were several tests which failed, several, it was half of them actually, more than 100. So this one was not good. This is why it was not deployed further to the production. Let's try the VARP now. So we might get some results after a few seconds, yeah. So everything good, only some information warning. So this is okay, but as you saw, other things were not okay. If I go to logs, I can clearly see that that some tests were failing. I can go inside and read more details, like I have the amount of tests which failed, and I have all the details in logs and so on and so on. So this makes our work much, much easier. I mean, the development teams to develop and troubleshoot and deploy thanks to these pipelines.
Yeah, and the other part of this NoOps approach is monitoring. So I will not tell about the monitoring that is in place, but I wanted to tell you about the approach we took. So within those release pipelines, aside the definition of the process for the deployment of the application, we have the configuration for the monitoring tools. So when the infrastructure pipeline deploys Kubernetes cluster, we also deploy daemon set, Kubernetes daemon set that allow us to connect to our monitoring tool. This is pre-configured, and it's automatic, so it's out of the box for AKS to have the daemon set for Azure Log Analytics. We are using this for logs monitoring. And the other part is App Dynamics, where we are.
Don't worry, it's just synchronization.
Where we are monitoring the application, the infrastructure, and we are able to use it for troubleshooting and seeing if there is anything wrong with the application. And for the application itself, it's also very easy because, as I said before, we are using Helm charts to deploy our applications, and there is a simple pattern to just attach the App Dynamics agent to each application. It is a little not significant overhead for the application to run. And then with the release pipeline, we have all the variables defined to connect this application to the proper monitoring view and see what's happening inside. So after deployment of an application, we don't need to care if the monitoring is configured, it just is. So this is very convenient. I would like to show you a couple of the screenshots. So what we have available, we can see the platform health. So we can see what's happening where, what's happening on Kubernetes, what's happening in our core system that platform is using. We can see the platform services if they are healthy. We can see what's happening in the application, if all the services are talking to each other and if everything is okay. So there are some response times, and there is a lot of options to, for example, drill down to see what actually is happening in the code, so there is a nice feature to see that afterwards. And it's all available just after having this all pre-configured in the release pipelines. And here is, for example, the Kubernetes board, that it's a bit of it just to have the visibility, it's there. So you can see the nodes, how they are behaving, how many of them is available, and if they are okay in terms of CPU, memory, etc., etc. And there are also some synthetic jobs that allow us to check constantly the health of the platform all the time. So based on that, we have some health rules defined on application level, synthetic jobs that are allowing us to do synthetic tests and infrastructure monitoring. And based on that, we have alerts, and that allows us to troubleshoot easily what's happening where. So this is basically it. And here I would like to say why we could do all of it. So we had great support for high-level management, I would say. So they were supporting us in crossing all these barriers between the teams. And we were constantly challenging the way something was done until so far. So this was a big plus. And also the approach we took is that teams are cooperating between each other. So we are breaking silos, and there is no ping pong allowed, I would say. So we are working all together. We are trying to work, for example, when we create tests, there is no development team who does the development and QA who is doing the test, and then there is some misunderstanding and discussions, etc., if the tests are fine or not. But we are trying to make it all work together. This is a journey, as I said, but we are trying to get there. Yeah, I think that's it.
Yeah, we changed quite a lot comparing to how we used to work a few years ago, and without this change, I cannot imagine that we could achieve something like this. So it's for sure require a different mindset and also approach from the top management, which, like Dorota said, really supported us. Okay, the last slide is about key takeaways. We'll see it in a few seconds, I believe. So I just want to put your attention to three things. So first one is that while doing something like this, you have to choose and decide where you want to invest, because you will be not able to do everything. You have to maximize your return on investment, so you have to decide. Yeah, and areas where you can focus. First one is the error-prone things. So when you expect to have issues, focus on these things. Automate the things which are recurring, so which you have to do often manually, and enforce policies validation. So if there are any policies coming from your company which you have to apply anyway, do it in automatic processes, which everybody can see it in advance and much earlier, and not be surprised at the end. Second aspect is to don't easily agree with everything what is happening in your company, and don't just accept everything what is required. And especially from non-business teams, you will get requirements. They will tell you that you have to do something in such way, you have to provide someone this and that, yeah, because they are used to it. But you have to challenge this. You have to ask and check if this is what they are asking, is it really relevant for your project? If it really has to be given, does it apply in your context? Because maybe you are developing something completely different, and you don't have to apply some of the rules. Even if you have to apply, maybe they are not that important, and you prioritize and you do them later, and you focus on the most important things. And also maybe you can satisfy them in different ways. So even if the teams are used that they got something in, I don't know, Excel table, because of your new technology, you do it differently, and you tell them integrate with this system and get the data by yourself, and don't wait for us to provide it to you. So you have to challenge, you have to do things differently. You have to change things, maybe like we showed you, some things which were always manual, you have to automate them, and so on. And the last thing to mention is that you have to remember that automation is not your goal. It is just a mean to achieve something. Yeah? Your goal is to provide a reliable solution, and automation is a journey from process to reliability. So keep that in mind. Don't try to automate everything, because first of all, you will not have time to automate everything, and also there is no sense to automate everything. And I think that's it from us. So thank you very much. If you have any questions.
We have 1 minute left.